All right, this is an extension of 1.7. Made this into two videos. Excuse me. We are starting with dividing rational expressions. If you remember last time, we were working on multiplying rational expressions. So to divide rational expressions, let's look at regular fractions first. If we have something like 2/3 divided by 3, which you write as 3/1, we would change that to be the first term would be the same, 2/3. This is regular division, so you've done this before. And we multiply by the inverse of this one. And this and that is 1/3. So we just took this one and flipped it upside down there. Now all we do is multiply, just like we did before. So this would be 2/9. That's regular fractions. So rational fractions would follow the same pattern, except we have x's and y's and cubes and squares and all those. So this is x/3 divided by 4x. So in order to do this, we will write it as x/3 and then change it to multiplication. That's a dot. And then flip the last one. So this turns into x times x, which is x squared, and 3 times 4, which is just 12. That's rational expressions. It's much the same way as regular expressions. Okay. So let's do an example. Let me get this out of the way so we can use this space. There we go. First example is a over a plus 4, a plus 4 divided by a cubed over a squared minus 16. A cubed over a squared minus 16. That's an a, not a 9. So what we do is we change it. We know that we have two terms, and we're going to start with the first one, a plus 4 times the flip of this, the inverse of this. So it would be a squared minus 16 over a cubed. Now, we do this just like we did multiplication last time. We see that we have an a here, and we have 3 a's here. So all we got to do is mark out one of the a's, make this just 2 a's. And this one, we have 1 a here, and we have 2 a's here. We also have a 4 and a 16. Excuse me. So how would we fix that? Now, one thing we haven't done is factor out this term. So maybe I got ahead of myself. So since I got ahead of myself, let me just fix myself. I was all excited to solve it, but nope. All right. Let's factor this one out. This guy, the a squared minus 16, we can pull out an a Okay, we can pull out. We know we can pull out a minus 4 from this. So we took a minus 4 out of this. That would leave us with a plus 4. Because we took the minus 4 out, it made that one possible. So this can be rewritten as a minus 4 and a plus 4. Since I didn't leave myself in the room, I'm going to get rid of these. Now we can start marking out stuff. So there's one A here, 3 A's there. Mark that one out, make it 2 A's. There's an A plus 4 here and an A plus 4 here. There, mark that out. So that leaves us A minus 4 and A squared if we did the multiplication. Now we need to simplify this further. We have 2 A's. Well, no, I guess we don't really. The reason is because this is a minus 4. This is a whole term. This is a squared, so we can't take those out. So this is your answer. All right. Let's do another example. I want to clean the screen up. Let's put in a space. The next one is x plus 3 over x minus 4 divided by, you'll like this one, x squared plus 6x plus 9. oh, Squared plus 6x plus 9 and x squared minus 2x minus 8. X squared minus 2x minus 8. All right, we need to factor out these trinomials before we can even start. I mean, we could go ahead and set it up as multiplication. So this would equal x plus 3, x minus 4 times, we take the bottom one and write it on top, x squared minus 2x minus 8. And then we take the top one, write it on the bottom. Okay. Now, let's factor these. We have a 8 negative. Let's start with that guy. 8, 8. Let's just do it down here. We have 1 and 8. We have 2 as the middle coefficient. This 2 right here. So let's say 2 and 4. So 4 minus 2 would give us 2, but it's negative. So the 4 is negative. Because 2 plus negative 4 is negative 2. All right. So we got our numbers. Let's go ahead and write this out. And I'll do it down here too. That way we can rewrite it up there. Let's go ahead and make our little things. X squared. And our last term is negative 8. And our middle terms will be 2x. That's a positive. And then negative 4x. So we need to factor out what we can. This one would be just x, so this would be x, and then x plus 2. This one would be 4. Let's do a -4. It'd be a -4. This would be x plus 2. And that makes x plus 2, and then x minus 4. So that's what this one's going to turn into. Let's go ahead and just erase it because we have already replaced it. And we don't have to erase it, we'll just rewrite it, but that turned into x plus 2 and x minus 4. Now, we have the bottom to deal with. Its numbers is 9 and 1, so just 9 is what we're dealing with. And we have 1 and 9. I don't think that makes a 6. 2 don't go in a 9, but 3 might. How many times? 3 times. 3 plus 3 is 6. Hey, look at that. All right, let's rewrite it. We'll move up just a tad. As our x squared and our 9 at the end, and then our 3x and our 3x, and everything is happy and positive. So we'll pull out an x here, and that will create an x plus 3 situation, and we'll pull out a 3 here, and that will create an x plus 3 here. And so we'll rewrite it as x plus 3 and x plus 3. So let's go ahead and remove this part. Oops. Oh, no. All right. And then x plus 3 and x plus 3. Now we can start killing off extra terms that we don't need. Here's an x plus 3, and here's an x plus 3. Here's an x minus 4, and here's an x minus 4. So we're left with x plus 2 and x plus 3. And there you are. The answer for that one. So that is dividing. It uses really multiplication to divide, but it's more of the same. It's just you got to remember to flip your last term here. Um, this whole thing, you got to flip it upside down when you rewrite it over here, then do the multiplication. Now we're going to look at adding and subtracting rational expressions. So the old way to do this, or the way you learned in elementary school, I suppose, would be, let's say we have two fractions, 2/3 and 1/2, and you want to add them. Now I write it that way because that's how I learned a long time ago. Um, so the first thing we would do is find the least common denominator. So the least common denominator would be something that would fit both of these. So sometimes what you do is you just multiply these two together. So this would be what, 6. So the least common denominator should be 6. Now, how did we get there? Well, here we did 3 times 2 equals 6. And this one would be 2 times 3 equals 6. Okay. And what we do to the bottom one, we got to do to the top. So this is 4, 6. That's a 3. That's 3, 6. Now, because the denominators are the same, we could just add them up. So this would be 7, 6. And that's our answer for the. So rational expressions would be the same way. Wouldn't be much different, except we have x's and x squares and stuff like that. So x over 8y plus x over 6. All right, now we need to find the least common denominator. And that's something that both of these numbers can go into. Now, an easy way to do this is multiply together. If you took 8 times 6, you get 48. That's kind of a high number. So there is a different way to find it. And that way is to just list out like, okay, 6 and then 8. Multiples of 6. We have 6 and we have 8. 6, you can basically count by sixes, or you can multiply by 2. So 6 times 2 is 12. 8 times 2 is 16. Okay. And now the next step would be to be like 6 times 3, because that's the next one in line. It's 18. And then the next one in line would be 8 times 3. That's 24. And what we're doing is we're going until we find a number of matches. And let's see, 1, 2, 3. Our next number would be 4. So 6 times 4. Oh, that's 24. So essentially what I did, I mean, you could write it this way too. If you say 1, 2, 3, 4, that way you can keep track of what number that you're multiplying by to get the number that's in the table here. You could even do it this way if you need to have it separated. Well, not so messy, but get the idea. But we found two numbers that match, so that's 24. So the LCD is 24 for these guys. And this table even tells you how you got there. 3 for 8 and 4 for 6. So 6 times 4, see 4 here, is 24. That's our common denominator. But what you do to the bottom one, you have to do to the top one. And that makes that 4x. This one is 8. It took 3. So we see 3 right here on the table to make 24. So 3. And this would be 24y. That's just like an x. Y. And then we do the same thing to the top one. That is a 3. Goodness. 3x. Now we can add. So, if you can't tell already that 24y is not the same as just 24. So, with rational problems, it's not just the number that you're worried about, it's the variable too. We should have multiplied by 4y. And watch, if I do 6 times 4y, that gives me 24y, which is the same as that one. If I do the same thing to both sides, I would get xy. We got to watch that when we're doing our practice equations. That's new for us. Well, kind of new. I mean, we do follow our move our variables around. So the solution to this is we do our addition, which would be just 3x plus 4xy. Now, because these terms are different, x is different than xy, we can't do anything else with it. We just write it down like that. And, oh, and this would just be 24y. And that would be the answer for that. Okay, let's do some practice problems for that. Go through them so that you understand how this works. Next problem is 12x squared over 5z plus 17x 4z squared. There. Now, first thing we need to do is find. Now, notice I'm doing it this way and not the other way. This way is more standard for most math realms, so we'll keep it in this format. We need to find the LCD, and the way we do that is that little chart. Here's 5, here's 4, 1, 2, 3, 4. I don't know if we need to go further than that. We'll find out. 5. I don't know. Okay. 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is 20. Let's fill out some of the 4s. This box. Okay. 4. 4 times 2 is 8. This one's 12. 16. 20. Okay, so this lines up this way. We found 20. These two match right here. So let's go ahead and make it 20. Doing it this way makes it a little more difficult to write it out like we were doing. So you know what? I'll write it out the way I've been doing it because it just makes it easier on me. I like easy. Let's write it this way. As long as the answer's right, it don't matter how you write it. 17x over 4z squared. All right, and we're adding. Okay. So we found out that on this one with 5, it's a z, and this one's a z squared. So we'll need to add z to this one, to the 5. So let's do that. This was a 4. Well, multiply. Z. Our answer is going to be there. And that will give us 20 z squared. Now, why to add the z? Okay, I added it because I know this is a squared. I need to meet what this one says. This one is just the 5. Other than the oh wow, the 5. So 5. This one equals 20 z squared. And we do the same thing to the top that we did to the bottom for both of these. All right, so 17 times 5 is 85. So we're 85x. This one is 12 times 4, which is 48, x squared z. That's supposed to be z. How about that? Oh, goodness. I cannot write z's, but that's supposed to be a z. All right. Now that we have that, we can do our addition. So our addition would be 48 x squared z plus 85x over 20 z squared. And that's the answer. Okay. Well, okay. Let me try another couple. Wait, what's division? Let me get this book working right. Uh-huh. All right, let me try another addition, and then we'll go into some great subtraction. That ought to be fun. Okay. This one is 3r. Okay, so let's write it. 3r over r squared minus 4 plus r over r minus 2. And we're adding. Yeah. How do we know what the least common denominator is in this situation? All right. This, okay, this can be done using our factoring skills for these. So the LCD, we can take this one and rewrite it as R minus 2 and R plus 2. Now, if you look back in the rules that they have a couple of chapters back, 2 or 3, you'll see this and you'll see that it factors out to this. It's a nice rule to have and a nice one to remember. Okay, so this, what did this take to make this happen? This took nothing, so we'll multiply by 1. To make this one do like this one, though, we would have to multiply by r plus 2. And this would be r plus 2 also. So this ends up being r plus 2 over r minus 2, r plus 2. And we're adding, so we write down our addition. 3r plus r plus 2 over r minus 2 and r plus 2. So you can write it as this, or we can simplify it, but this is acceptable for now. All right. let's try another one. Okay, so 12q squared. Not okay, so q squared plus 8 squared. 8, no, I'm sorry, not squared. Oh my goodness. 8q plus 12 plus 4q q squared plus 2q minus 24. So you probably already see what you need to do. These trinomials need to be broke down into factors. So I guess let's get to it. For this one, we have 9 and 12 for grouping, doing by grouping. So 9 times 12 is what? It's 108. So let's take 108 and let's write the factors out. Now, we need to get the factors that are close to 8. So factors that are close to 8 would be two numbers that are pretty close together. So writing down 1 and 108 is not going to be useful. So what numbers would be in there? So we know that 108, we could probably fit what? 108 divided by 12? 12 and 9. Let's see. Is 12 and 9 enough to make 8? What do you think? Do they need to be spread out some more? Yeah, they definitely do. So let's try a different number. So we know 11 probably won't work, 10, but what about like 108 divided by 8? That don't work. Or 108 divided by another number. What about 6? So 6 will go into it 18 times. Would that work to get us 8? Nah. Yeah. So we need to keep looking. Um, divided by okay, 8 divided by 14. No. Eight. Hmm. You know what's really funny about this? It's not 108. That 9 that I thought was sitting there, it's actually a Q. So this is a Q. It's not a 9. I got to remember that on both of these. Evidently, I don't know how to write Q's without making them look like 9s. All right, let's start again. So it's just 12. 12, we need to make it look like 8. So 2 will go in 12 6 times. 6 plus 2 is 8. So let's do that. So this will factor out. You know what, let's do the factorization down here. Yeah, kind of out of the way. So Q2 and 12, and then our numbers plus 2, and then, oh, I'm sorry, Q, and then 6Q. Let's pull out our common ones. So here we have a Q, and this is a Q plus 2 And here we have a 6, and so we have a 6, just a 6. And that's a q plus 2. So it would be q plus 2 and q plus 6. So the thing is, though, we have to do the same thing to the top one we do to the bottom one, or do we? So no, at this point we do not, because we are simply factoring. We're rewriting this as fact. So this first step of factoring, we don't have to do that. That's not the same step. We're not finding the LCD yet. We are doing just factoring right now. All right, now let's factor this bottom one. Well, I'm gonna make some space down here. There. And here. We'll just do the next one. This one has a 24, and that's not a 9. So, and the middle number is a 2, a positive 2. So to get a positive 2, we probably have two numbers that are fairly close. Maybe. So it's probably not 2 and 12. 3. What about 3? How many times is 3 go on 24? No, nothing. It's 8. So is 3 times 8 24? Yeah, of course it is. But how do we get 2 out of that? So 8 plus 3, that's not going to work. So what about 4? Does 4 go into 24? Yeah. So 4 goes into 24. It's a 6. Ah, the difference between these is a 2, a positive 2. So this is where we get the 24. So if we did 6 minus 4, we'll get a positive 2. There's our numbers. So let's write it down. We have our q squared, our 24. This is a negative 24. And then we write down our negative 4x cubed, sorry, and our 6 cubed. Pull out like terms. This one's just a q, and this will be a q minus 4. And then pull out like terms. This is just a 6, and this would be a q minus 4. So what we're left with is q minus 4 and q plus 6. So this is a q minus 4 and a q plus 6. All over a 4 q. Now, we need to find the LCD. I'm going to make some space. Because I believe we're going to need this space. The LCD of these is actually quite easy. You see what's missing. I mean, we have two q plus 6s, but this side doesn't have a q plus 2. I mean, sorry, this guy doesn't have a q plus 2, and this guy doesn't have a q plus minus 4. So that's what we do. We basically multiply both sides by what's missing from the other side. So this one is missing a q plus 2. So we're going to multiply q plus 2 from both sides, or on both sides. Sorry, not from. And this one is missing a q minus 4. So we'll just multiply a q minus 4 on both sides, or both top and bottom, numerator and denominator, and we'll get 12. Okay, so we'll get 12 q squared q minus 4 over q plus 2, q plus 6, q minus 4. Let's see. This one will be 4q q plus 2, and then q minus, well, I mean, if you want to make it look the same, you can write it in the same order as the top one. But order really doesn't matter unless you're doing some sort of grouping for ascending powers. But this way it should be fine. So q plus 2, q plus 6, q minus 4. Okay, now we can add because our LCDs are the same, which will make a big old long um, equation, but that's okay. So let's write it as 2q squared q minus 4 plus 4q q plus 2 over. Is there a way to copy this? Because good grief. There is. Look at that. Look at that. That. I should have done that before. All right. That is the answer. I didn't look in the books and let me verify with the book. Okay, so they just expanded. They simplified the top section. Um, and you can simplify the top section too. But what you would do is basically do the distribution method. You would take this and distribute into here and then into here. So you'd have 2q to the third minus 8q squared plus 4q squared plus 8q, something like that. Then you can simplify like terms, but I run out of space. So I think we're good. If you get to this point, I think simplification is the least of your worries. I think you can simplify this on your own pretty easily. All right. That was addition. You ready to do some subtraction? Subtraction is pretty much the same. There's really not much different. You still have to find the LCD. You still have to do the process. And you just subtract it instead of addition. If you noticed, all we was doing is writing a plus sign in between the terms. So, for example, let's just do 1. 21R4 over 6Q. And then we're subtracting 13R over 4Q squared. Make sure I wrote this correctly. Yes, I'll do that here. Okay. Now we need to find the LC, and this is subtraction. So LCD on something like this is a little simpler, maybe. Um, so we could say that it is LCD of these two numbers, 6 and 4. 6 and 4. We can make our little table. 1. See, I don't know why I write 1. We know it's not going to be 1 because that's why we're here. Anyway, so this would be 6. This would be 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. 6 times 2 is 12. Oh, there we go. We found it. So on the 6 side, all we did was multiply by 2. Now, what we need to do is get to this q right here. So we'll need to add a q to this guy too. So we'll multiply by 2q. So it'll look like this q down here on both sides. And that will give us 21R4 times 2q. Okay, let's do that. We got 42R4q. And then this is our least common denominator. And it's going to be 12q squared. Because it's q times q. Now this one, we're going to do the same thing on both sides. The 4, it was a 3. So this 4 and 3 made 12. So this would be a 3, and this would be a 3. Now, why is it not q2? Well, because we already have a q squared here. We don't need to add a q2. So this would be 3 times 13. 13 times 3, 39. Really? I don't know why I had a different number in my head. That's why I checked it. Okay, 39R. And then this would be 12q squared. Now we can just subtract. 42R to the 4th q minus, not plus, but minus 39R over 12. And that's subtraction. So you're basically doing the exact same thing, but just using subtraction. Okay. So what I want you to do for this lesson is you've already done practice 1 through 26. You've already done those. This time I want you to do numbers 27 through 47 for you. So 1.7, 27 through 47 blue. And good luck.